Hi, I'm Pete and I'm here today to talk about the ARTES machine, which is for seized fastener removal. This machine is for automatically removing screws which are stuck in components such as turbochargers we've got here today, and that could be in the automotive industry or the rail industry or oil and gas and things like that. So I'm going to talk through some of the key features of this machine. As you can see behind me on the right hand side, we've got a tool changer here which is for 6 electrodes, and basically you can have different sizes of electrode in there. So if you've got several fasteners which are seized or common ones which you keep doing, you can do all different ones in the same job. Or alternatively, what you can do is you can have a set of all the same electrode, and as these wear down, it will measure them, it will know when it's going to run out, and it will automatically switch to the next one when the electrodes run down. So that way it's a really automated process, and it can run for over an hour without any operator intervention. Obviously this is really good in that it reduces the labour costs associated with removing seized fasteners, which is a typically very labour intensive process. So we have a unique feature on the ARTES machine in that the bed moves up and down, and it moves quite a long way, about a metre, and that's to enable you to put in both really big parts and also really small ones. But also when you're unloading and loading the machine, it means that your operators don't have to lean over too far, and that's much more ergonomic than many other machines which are similar to this. You can load it through these nice wide opening doors, or we also do an option where we can have a hoist load the machine as well. The machine uses a standard type of tool holder, an ER20, ISO 20 tool holders, so that means you can really quickly and easily swap them over like you would with a machine tool. So typically with this machine we remove screws which are between 3 and 12 millimeters diameter, but we can work around that as well. We can do slightly smaller or larger ones, and we do this without damaging the threads in the component. So essentially most of the time we'll drill through the core of the screw, and then you'll be able to remove it quite easily. So something which we think is quite unique in this machine is that you can use different sized or shaped electrodes to remove all different kinds of fasteners. So for example, if you've got one which is seized but you think you'll be able to undo it, you can machine a hexagon shaped hole. So we don't just have to drill round holes with this machine, we can also drill hexagon shaped holes or square holes. Those then can be impacted out later or unscrewed using a conventional tool. The automated jobs can be set up in a number of quite sophisticated ways. So we have a camera mounted on the side of the spindle there, and you can actually drive that to the position, set the position using the camera, use that using a reticule on the screen which you can set to the size of the screw. It saves those positions, it then knows where the screws are, and then when you press run it will just go to those set positions you set from the camera and automatically remove those fasteners. So no CNC operator experience, no G-code experience is required, so it's really easy to set up for even someone who's unskilled. Another way that you can set up the machine is using automatic probing. So if you get rough locations of screws which have heads on, what we can do is we can probe different points on the side of the head, and if you've only got a rough location to begin with, the machine will automatically calculate the center of that screw and it will machine in that spot. Crucially, it's not tied to those locations. So if you've got castings where there's differences in every different part, then it will probe those every time, even though the rough position that you've set inside the code is the same. And that means that even though the actual centers of the screws are changing, the machine will always hit the dead center of the screw. So you can fill this machine with tap water, which it then automatically deionizes. You don't need to connect it to a constant water supply or anything like that. It's got a tank built into it. And in that way, it will keep the part cool, so the temperatures never rise above sort of ambient temperatures, and it removes those screws using that spark erosion process. Unlike a conventional machine, like a milling machine, we don't use physical contact or chips to remove screws or to remove material. We use sparks. So this process uses electrical discharges thousands of times a second to erode away the screws that you have there. So it's no contact, no force, and no heat. And what that means is your fixturing can be much more simple. You can just use things like 3D printed fixtures, or very minimal or even no fixturing using our perforated bed that we have here. So that makes it very simple to set up new parts. You can quickly change that bed to put in a new variant of parts so that you don't end up having lengthy setup procedures every time you want to move to a different component. Unlike other machines which may be similar to this, the ARTES machine is also set up for high automation to reduce labour costs, as well as high-speed machining so you can keep the throughput really high. So to do those things, we have really high pressure dielectric fluid, and we also have a very fast spindle speed, which is not possible on many other machines. As well as that, because we have a different type of tool holder, we can do much more varied sizes of screws than you might see with other kinds of electrical discharge machine.